Welcome everyone to today's session. I hope that you're all enjoying the conference and that you're having a good time. My name is Christos Matskas and today I'm here to talk about security. Why? Because I'm passionate about security and because I know that security for many of us is a difficult topic. It is a pain in the backside when it comes to security because it's such a massive topic. You got hardware security, information security, application security, infrastructure security, and then within all these things, within all these areas, you have subsets and more subsets. So it's very hard to talk about security even when we need to, focus down on specific things. Even on today's session, we're going to cover just a very small subset about secrets in applications and how to remove them and make our applications more robust. A little bit of background for me. I've been in IT for over 18 years now. I've been predominantly a developer working with the .NET stack, but I've touched Python and .NET, and I'm passionate about security, as I said before. And hopefully after leaving today's session, you will know how to deal with the pests that are secrets in our code. Because trust me, over 18 years, I've seen all sorts of things. I've seen customers doing some really silly stuff. And for me, it's a big concern because it's very easy to take that information and abuse it. Outside of work, I try to stay fit by competing in triathlons. Why triathlons? Because it's probably the only sport that combines the three activities that I hate vehemently: running, swimming, and cycling. So cybercrime. Yes, cybercrime is the things that we have to all be aware of because it's everywhere. Online transactions, applications, anything we touch, anything we build. And cybercrime is something that really pays well. Before I get into the figures, let's look at a very simple example. Let's say that you wanted to create a spam service to make some money. Now, I'm not saying that you should be doing that. I'm just saying that if we were to build something like this, it would cost less than $100 to spam 1 million people. You can get a lot of things for free today. You can get services and servers to run infrastructure and code for free. You can get lists of people and contact information for very little money. And you can even get credit card information for about $2 a pop. So let's say if we were to spam 1 million people and make some money, then I would say an average cost would be about $100 to run this solution. $50, $70 for running 5 to 7 servers. If not for free, then about $10 to $20 to build a very basic website with some templates that you can even buy out there. So many available. And then finally, to get a list of 1 million people, it's about $10. So that's $100 to run this operation. Considering that a credit card is about $2, then all we have to do is to hit 0.005 or 50 people in that list, get them to buy it, and that would actually get us all the operational costs. Anything above that is going to be profit. You've seen spam email, right? Your spam ends up in your spam folder and you can see them and they're awful. Imagine if somebody were to put a little bit of effort to fix things like typos and pictures and the grammar. Then these operations would be quite a lot more profitable. Because even with so much laziness out there, people are successful. Now, I did say that many of these things are available to you for free today. And it comes as no surprise that Heroku just decided to stop their free tier. They decided to stop their free tier because they were spending a lot more time trying to deal with fraud and resource abuse than actually building features and capabilities on their platform. Just goes to show that the hackers are being a lot more clever in benefiting from free resources and software out there. Now, I did say that cybercrime pays, and it pays really, really well. Just for 2023, the annual loss is projected to be about $6.5 trillion. That's an insane amount of money. The average damage to an enterprise is around $4 million, and in some cases, if you are a small or a medium enterprise, this can be the end of you because you may not be able to recover from such a hack. And the number of stolen records per hack is about 25,000 individual records. Hackers walk out with that information and they can cause a lot of damage or sell it. We talked about secrets. And this is why secrets are so valuable to hackers, because hackers today don't break in, they log in. It's very rare that you'll read in the news that there was a 0 day in an operating system that was taken advantage of, or something in your web browser that will allow hackers to execute unauthorized code. Hackers will go for the easy path, whether that's something on GitHub that you uploaded by mistake, like an API key or your storage keys, to social engineering, trying to get information from people, because we are always willing to help. So as long as they have enough information, and they can get all that for free again through LinkedIn and other resources, so it's not very hard for them to build a proper social engineering attack, they will find the easy way in, and that's a major problem. And we also know that users can be lazy. Just the other day, me and my wife went to the bank to get new credit cards and debit cards, and the customer representative there asked us, what would you like for your new PIN? You can type it here on the keyboard. And my wife leans in and says, what is the PIN I used to use all the time back in the UK? I said, I'm not telling you. You have to figure a new one. Why did my wife do that? Well, because users like convenience over security. Why not use the same PIN across all my debit and credit cards? It will make life so much easier. I don't have to remember all these things. Same for online accounts. Why use different passwords when all I have to do is just type password or 1, 2, 3, 4, 5. These passwords over here are actually popular passwords per country. So password is very common and very popular in the US, whereas 1, 2, 3, 4, 5, 6 is very common in Germany. And then QWERTY is very common in Russia. You can find whole lists of popularity per country, and then you can use that information to launch attacks. People are lazy. Now, if you don't use a password manager, or if you haven't heard of a password manager, I would urge you to go out there and look for paid or free versions, but please stop using the same passwords. I have over 700 passwords and accounts online. I don't know a single password. So if my password manager was ever to die or go away, I will be absolutely doomed. In saying that, password managers are very helpful, but this is something that tech-savvy people are okay with. Imagine older generations. Imagine your grandparents or your parents trying to be safe online. So we do have a responsibility as builders, as developers, to build solutions that are a lot more robust and to help our customers and their data to stay safe. Whether you're creating a customer-facing app or whether you're creating an API that needs to interact with other customers and businesses out there, we have a responsibility as builders to make it secure. And there are all these horror stories out there. Just last week, there was this lady in the UK, Charlotte, that went to her gym. She left her phone on the locker. The entry barriers were broken, and people came and stole phones and bags and what have you. And they also took her phone. What happened next is even more horrifying. I have the full Twitter thread here. You can go and read about it. But the bottom line is that they used her phone to actually gain access to her banking information. And then they went and emptied her bank account. They went on a shopping spree. They were able to transfer funds. There are some questions there with regards to how they were able to gain access. But when her bank was trying to access her to let her know that there were some unusual transactions, they were actually calling her phone. Whoever got hold of her phone was able to go back and say, yeah, that was me, which is crazy. And these stories are littered across the web. This is just the one that made the news, but imagine how many other people have had the same kind of frustration and they never made the news. Every week we hear about another website and another company being hacked. And all that information ends up in the dark web, where people can go and buy it. But there are also people out there that look out for you. So if you haven't heard of Troy Hunt, a security consultant from Australia, and his website, Have I Been Pwned? And I would urge you to go and have a look. As you can see, he's collecting information about all these hacks and uploads into his website, where you can go and find whether your account was ever hacked in one of these 628 pwned websites. There are 11.5 billion accounts that have been exposed across 115,000 pastes. This means that if you go to the website and put your Gmail or your Outlook or your Hotmail or whatever account you use, your Yahoo, then you can find whether your account ever made it into one of these hacks and go and change your passwords. I would also urge you to sign up for alerts, because every time a new hack happens and Troy uploads the data, you can find whether your information was included there and go and change passwords. Ideally, you have very strong passwords that are unique across every single website, and therefore you don't have to worry about changing passwords. But for people that reuse, and we did say that a lot of people reuse their passwords, this is going to be a major problem, because that information can be used to sign into their Netflix accounts, their Facebook accounts, and then start abusing friends and relatives by asking for money and what have you. There's a whole use case out there about how over $200 million were lost by people impersonating somebody else, getting access to their Facebook account, and then reaching out to relatives and pretending that there was an emergency and asking for money. See? So you go from this totally innocuous, random website that you used once to buy a beanie for winter, to actually having that account being reused across multiple websites, ending up costing you money. So I talked about users and how they are lazy, and sometimes we are the users, and sometimes the applications we build are used by our users. But as builders, as developers, we also have a responsibility for building things right. This is a very recent article that was published by Symantec, where they took a small sample of mobile apps that exist in the market, and they reverse engineered the code, only to find that in 1,859 of them, there were hard-coded AWS credentials. Think about that. Over 3/4 of these apps contained valid AWS access tokens to private AWS cloud services. Once somebody gets hold of your resources, then they can use that as a launch platform for other attacks. And then over 47% of them had valid access tokens to private S3 accounts with millions of private files. These files are not related to your application, but exist in the same S3 bucket. Now, this is bad practice, and I wouldn't say that this is right, but this is something that can actually happen. So there you go. We are at fault as well. If what I've said so far causes you to feel like this, despair not. It's not an unusual feeling. I feel like that most days, especially when it comes to security, because security is hard. Whether we like it or not, we play catch up with the hackers. They're always one step ahead. But that doesn't mean that there's nothing that we cannot do to help alleviate some of these risks. What do I mean by that? Well, in today's session, if there's only one thing that you take away, is that I don't want you to ever use secrets in your code again. Anything that can be used to gain access to your resources, connection strings, API keys, any sensitive information that needs to be used by your application needs to be offloaded into something else. What is that something else, you might ask? Well, most cloud service providers out there provide you with the capabilities that you need to build robust solutions, especially when it comes to offloading your secrets to something else. And they tend to be very comprehensive with language support. Therefore, whether you prefer to use Python or .NET or Ruby or Node, there are SDKs and there are APIs that you can use in your code to access these services. Let's start with the AWS Secrets Manager. As the name suggests, this is a service for you to manage secrets. It allows you to store secrets at rest. That's very important. You can use your own keys, or you can use the AWS Key Management Service, the default keys in your account. And when you retrieve your secret, the Secrets Manager decrypts your secret using the key that you have defined and transmits that over TLS. So it always comes over SSL. By default, the Secrets Manager does not write or cache the secrets to persistent storage. And the important thing here is that not only do you offload the secret somewhere else, but you can also have very strict control of who can access these secrets and how, using identity and access management policies. And you can also tag secrets individually and apply tag-based access control. You can group them together, let's say under the production environment, so you can always specify policies for that specific environment, and what have you. Storing secrets outside of your code is very important, but one of the things that we really don't do well is rotating our secrets. That's a major challenge for most of the enterprises out there, because once something is out in production, is working, we don't touch it. But secrets need to be rotated. There are ways to do that through the SDK, through the CLI, or through the management console. Ideally, developers should never have access to production secrets, so somebody else should be dealing with that. And the secret rotation in AWS Secrets Manager is actually quite smart in the way that it can rotate secrets for you automatically for certain services that are hosted in AWS, like Amazon RDS and Amazon DocumentDB, or clusters hosted in Amazon Redshift. For all other cases, you can build a Lambda function to rotate secrets for you based on your requirements. And this secret rotation is totally transparent to your application. Your code never changes. You always reference the same secret, and you always get the latest version unless you want to pin to a specific one. And as with all infrastructure, no service would be good if it didn't allow you to replicate and plan for disaster recovery and high availability. And with AWS Secrets Manager, you can replicate your secrets to multiple AWS regions to meet your unique disaster recovery requirements. You can do that through the console, you can do it through the CLI, or even through AWS CloudFormation. So you can specify the regions where you want your secret to be replicated. And the nice thing is that the Secrets Manager will securely create regional read replicas. Remember, these are only going to be read replicas, no writes. And that will eliminate the need to maintain a complex solution for this functionality. This is something very tricky to implement yourself, and it's nice to have it out of the box. Our secrets are stored in AWS Secrets Manager, and now we can use the SDKs, the CLI, or CloudFormation to pull the information out when we need it. And there are different ways that we can do that, but with the SDK and some solid IAM policies, we can make sure that our code only pulls information from where it needs to. And by using a VPC, you can also keep traffic between your VPC and Secrets Manager within the AWS network, so it never goes out. And finally, for those specific scenarios that we needed, we can use client-side caching to improve availability and reduce the latency for using secrets. Storing secrets is very good because it offloads them from our code. We can now use them through code. And then we also need to know who's using the secrets. That's very important, because if you don't know how your secrets are used or where they're used from, there's very little that you can do to protect your resources. Secrets Manager provides the availability to enable AWS CloudTrail for a specific region and get notified when a secret is rotated or stored or something like that. Finally, let's talk about compliance. AWS Secrets Manager is designed to be compliant with Department of Defense Cloud Computing security requirements, or HIPAA, or Information Security Register Assessors, IRAP, etc., which is very important when it comes to building solutions that need to have this kind of compliance. And now that I've convinced you that you should be using AWS Secrets Manager, you may ask, what is the cost? I would say there is a cost associated with using the service, as with everything else. It's not free, but from my perspective, I do believe that this cost is negligible when it comes to reaping the benefits of using such a service. With a 40-cent dollar, it's 40 cents for each secret that you store, and then there is an API call cost. But from my perspective, building such a robust and geo-replicated solution that allows you to not only store but rotate your secrets automatically and have that reflected in your code is invaluable, and something that is very hard to build yourself. That was the first option. However, there's another service that allows you to store secrets and use them in your code. The AWS Systems Manager provides a centralized store to manage your configuration data, including the parameter store, where we can store things in plain text or secrets such as passwords, API keys, and what have you. These parameters can be tagged and organized into hierarchies. They can also be reflected in your configuration file. And the important thing is that it also integrates with the AWS KMS service, the Key Management Service. which means that now you can either use the default keys or you can bring your own keys to encrypt and decrypt the data that is stored in the parameter store. And then we have things that can be applied on top of the parameter store, like the built-in IAM policies, or you can build your own custom IAM policy to be specific to your code. And I will always advise that, because we always want to follow a least privileged approach when it comes to giving access to resources. And these parameters can then be referenced by AWS services as well, like Amazon ECS or AWS Lambda, AWS CloudFormation, and what have you. So we can store parameters or secrets. The other benefit that you get with the Systems Manager parameter store is that you can now plug in directly into the configuration settings for .NET Core, .NET 6, .NET 7 applications. So when you bootstrap your application, you can load all the config settings that you want up front rather than doing it on demand. And it's free, which is probably one of the most important things. But you don't get the other benefits of the Secrets Manager, which is auditing and compliance. So you need to choose the right service that is more appropriate to your solution. And with that, I'm done with my slides, which means that we can jump into the code and have some fun learning how to build code that benefits from these two services, and then eliminate the need for storing sensitive information in your code. Well, I did promise you code, and code we shall see. We will start with the Secrets Manager, which we're going to use in our .NET API to pull secrets out. We'll start with the Secrets Manager because that's the service that most of us should be using today, because of the robustness, the replication, and the auditing. There's an SDK for .NET, so if you were to start, you will need to download the AWS SDK Secrets Manager and grab the latest version. We are also using .NET 7 for most of our examples today, but everything that we see is also compatible with anything that is .NET 3.1 and above. Once we download the Secrets Manager, then we can start implementing some code. So this is a minimal .NET 7 API. I'm referencing the namespaces, and on line 12, you'll notice that I'm injecting an Amazon Secrets Manager client. You will also notice that I have defined the region. You don't have to do that if you already have it in your configuration file. And because I'm running locally, I'm using the credentials in my code. This is something that I want to highlight, and that's something that is very, very important. The code should remain unaffected going from developer to QA to test to production. And that's the whole point here. When developing locally, we need to use credentials, but when we move to something that runs on AWS, then we can use instance roles to allow us to pull these secrets. And for every role that we create and every credential that we create, we need to apply the appropriate IAM policies. And by IAM, I mean an identity and access management policy for those ones that are not accustomed to three-letter abbreviations. And because I have already registered the service, I can dependency inject that into my API methods. We have a get secret and we have an API weather. In the get secret, I can pull any secret I want by passing a name of that secret. But we'll also see whether I can pull every secret or not based on my IAM policy. And then in the API weather endpoint, we actually call an external service with the information that we retrieve from the Secrets Manager. You notice that the API key secret string allows us to make a call once we retrieve the secret. So let's run our code and take it for a spin. The API is up and running, and I'm going to use my favorite tool, Thunder Client, to make a call for get weather. We're looking for the weather in Seattle. Let's change it to Holliston, which is where I am today. And lo and behold, we have our data. The data came back. Let's see what happens when we run the get secrets. First, I'm going to call that's the value, some random secret from Secrets Manager. But if I were to change that to a different secret I have stored in my Secrets Manager, boom, an error message. Check this out. My account, which is currently running this application, is not authorized to perform a get secret value because there's no IAM policy that allows you to do that. Let's see how I implemented this kind of policy. We will switch to my AWS console on the browser, and here we're going to go to IAM conference Wi-Fi, right? I'm just kidding. I wish I was there with you. I'm not. I'll make it up to you next time. This is the policy I have created. CM read-only secrets demo. As the name suggests, this is only for our demo today, but you can create more persistent policies. I want to look at the permissions here. This is a box standard read-only policy that I retrieved from the documentation. And this is to allow us to read specific secrets, but when it comes to resources, I am being very explicit about which secrets my application and my user can access with this policy. Therefore, only these two secrets that we have, the API key and my DynamoDB connection string, were configured to be accessible by that user. We will apply the same policy to the other roles when it comes to running in different environments, and therefore we have a consistent experience. You could also have different policies for dev, QA, and production, and therefore applying the appropriate least privilege principle to different keys, because the key I'm using in development should never be the same key I'm using in production when it comes to accessing database resources, for example. There should always be this kind of gap, because as a developer, I could always step through my code and look at the keys in production. I don't want that responsibility, and the company should not give that responsibility to me. If there is an emergency in production, there should be a break glass process where somebody can retrieve the secrets to allow developers to temporarily debug code in production, if that is the case, and we need to do that. But we should never ever give developers production access, and developers should never ask for production access unless there is an explicit need for it. Okay, so we have the policy there and we saw the code working. I want to go back to the code because I want to highlight how little code it took to implement everything. There are 2 lines, 12, 13, and 14, that inject the service. And then within my code, I have 4 lines to retrieve the secret. It only takes 6 lines of code and 1 library dependency. And with those 6 lines, I have totally eliminated the need to store my secret in my code. At this point, I want to move to the next service, which is AWS Systems Manager, and see how we can use that to populate our configuration files. Let's change branch. Run .NET Restore, because we're in a new branch now. And subsequently, let's look at our code. Remember this file, the app settings.json? There are cases where we might want to upload upfront configuration settings because they need to be used as we bootstrap our application. They could be used by the middleware, they could be used by other things, and we want to have those values pre-populated. We don't want to have anything in here. If I ever come to you and I see these populated, then we are going to have a chat. Because after today, you shouldn't have the need to ever populate these with anything. Let's look at how you would do it. In .NET, we can have multiple providers for the configuration. Some of them are the local secret store that you can use to store secrets. That's an option for .NET, but personally, I don't like that because these configuration settings end up in clear text under your profile. If anyone were to gain access to your PC with your profile, let's say through a phishing attack, then they would have access to these settings. This is a well-known path that anyone that has looked in .NET will be able to quickly go and figure out what these values are. I tend to avoid the local secret store, but it is an option which is better than putting these inside your code. It's one step above, but we can take it all the way further to making it secure. As we mentioned earlier on, Systems Manager allows you to tap into the configuration providers and actually populate settings with parameters that are stored in Systems Manager Parameter Store. The nice thing about Systems Manager is that it also allows you to reload your configuration settings from the remote store by defining a specific interval. So lines 9 to 17 do exactly that. They say where our Systems Manager is located, what the path for our variables can be, and this can also be a parameter that comes from your app settings.json that can be changed based on the environment that you are. Therefore, this could be prod. And finally, we say how frequently we want to refresh from the store. When the application starts up, anything that exists in our app settings.json and is found in the parameter store, as long as they match, then these values will be populated at startup. And then we can use that information in our code. We have two methods here again. We have meteorites. So if you are passionate about how many meteorites have made it into Earth, there are actually quite a few of them. You can run this API call here, which we will run in a second. And then we have another one for weather. We'll run this again. But you will notice that in our code now, when it comes to pulling information out from our weather API, the third-party service, again, we pass the API key that it is populated from the config. So line 35 does that. It says, I should have an API key in my config, go and get it for me. And as before, not only do we have the parameters stored outside of our code, but we also have an IAM policy that restricts access to read-only. I did go with the default one this time. So if we go back into our users, then my secrets reader, the one that we're using for running this application, has the Amazon SSMS read-only access. Unfortunately, this gives you access to all the parameter store parameters, which is too wide. I would copy this one and lock it down to only the specific ones that you need for your application. We don't want to give unfettered access to everything. Let's go back to our application and let's see what happens when we run it. Another important thing that I want to highlight, and we need to quickly jump back into our policies, is that this specific account also has access to our DynamoDB database and has read-only access because we're going to pull some information out. Let's jump into our Thunder client. Let's get our weather, which remembers that I'm still in Holliston. That all works out of the box because that information is populated. If there was an issue with the policy, you would see the code crashing at startup. So .NET Run would not even execute because it was not able to populate a configuration file. If I run a get secret, now we can get the meteorites out of the database. So let's search for any meteorite that starts with the name B or contains the name B. Quite a few of them actually. And that's it. Again, let's look at the code and how much it took to configure all that. We have 8 lines of code or 7 lines of code between 10 and 17 that configures our Systems Manager. And we do have one line, 35, to pull the specific configuration setting out of the config. There is one NuGet package that you need to install to allow this to happen, and that is the Amazon Extensions Configuration Systems Manager. And that allows you to use the AWS Systems Manager in your configuration. This is all nice and dandy, but you might ask, okay, Chris, what would happen if I am using Systems Manager, but I don't want to upload all my parameters up front? I want to do runtime queries to the Systems Manager. Well, that's what the next solution is all about. Let's do this. So we're going to stop this application from running. We're going to check out all changes. Okay. Let's close this one. Don't save. And then we're going to switch a branch to git checkout AWS Systems Manager runtime. Let's do a .NET restore again. Clear the console. And now let's have a look at the code. There is a small difference. We do have a new package called AWS SDK Simple Systems Manager, SSM. Our code is different because instead of loading everything up front, we're going to do it on demand. So let's open our program.cs. We do have the Systems Manager still here. I left it there as we are evolving the software, but later in the code, we do have a get value from parameter store. That's a helper method I built. So 97 to 105 in 8 lines of code. We create a simple systems management client. We give it a region if that's not defaulted in our settings. And then we get a result back and we pass the value to our code. And that gets called in a couple of methods. So now we can go and run this and see what happens. I also think I added an additional method here. Again, using the list privilege, I wanted to test what would happen if we were to upload a meteorite. Remember, our IAM policy for DynamoDB is read-only, and we want to test what will happen if we were to upload a meteorite. We should get an error message. Okay, our code is running. So let's go and get some meteorites out. That's working. Go and now get a secret. That is working. I do believe I have a .NET My Secrets in my Secrets Manager. That worked as well, and that worked because our IAM policy allows us full access to all the parameter store values, encrypted or not. We can get the weather, and finally, let's go and put a meteorite there and see what happens. We'll name that meteorite Christos. I've copied the values, it's a unique ID up here, so let's send this out, and we should receive an error message. That is because our IAM policy restricts access to read-only and doesn't allow this specific user to upload or create new records, which is great. Based on our information, you can see that using a clever combination of IAM and then using the right services, we can offload the responsibility of secrets into AWS, which is now responsible for storing and replicating our secrets across the board. And we saw 3 different ways for pulling the secrets out, using the Secrets Manager, the Systems Manager parameter store for configuration, and the Systems Manager SDK or library for runtime access. I would say this is only a starting point. For all these things, we could also apply authentication and authorization through forcing people to sign in or applications to sign in and get a token from AWS Cognito, therefore enforcing another layer of security on top of these things. APIs should never run insecure like we have them open here, because if the API endpoint can be found or is discoverable, then anybody could be able to access and call certain services. So even though the API is running under the context of a specific user, access to that API should also be managed either through a getaway or through a getaway and something like Cognito, which enforces authentication and authorization. So all these methods that we have in program.cs could have an authorization tag to say who and how they can access these APIs and what they can do. So just because the API can write into the database doesn't mean that everyone that uses the API should be able to write to the database. And I did promise you an example using the CDK. Let's switch to that and see how DevOps can benefit from services like Secret Manager to remove secrets again, because it's not just builders and developers that will be building code and running it, and sometimes we throw it over the wall to our DevOps friends to deploy somewhere. Sometimes we write that code, sometimes there are other people in the organization writing that code, and we want to educate them about how to do it right. I have an AWS CDK.NET example that deploys a service to AWS, and it has to use a secret because it is a database. So let's see how you would do that. This is my CDK project. If you are aware of how the .NET CDK projects work, there is a top-level CDK JSON with some README information, and then there's always a source where our code goes. The program.cs is our starting point, our entry point to the application, and then you write multiple files with the stacks that you want to deploy. In this instance, we have an RDS database that we want to deploy. You will notice on line 12, the first thing I do is to pull the secret from my secret manager. And for that, we do have the CDK Secrets Manager library, which is built on top of the standard library. So we're not using the SDK, we're using the CDK specific Secrets Manager library to interact with the Secrets Manager in one line of code. And then that secret then gets passed down to our database instance under the credentials. So we're creating a credential from secret, and we're passing the secret with RDS God as the admin. when it comes time to run this, .NET build src, make sure that everything is building and working as expected, and then ctk synth. CTK synth will look at the code, it will compile it, it will output a CloudFormation file. But you don't have to use that one. CTK build will straight away deploy your stack to your AWS infrastructure. However, what I wanted you to look at is under master user password, you'll notice that instead of having a hard-coded value, it references the secret manager parameters that we passed in. And even though we are using the value in the code, right, from secrets, it never pulls the value in the CloudFormation file, keeping everything secure and only pulling that information when doing the deployment at runtime, which is super awesome. And that means that whether you prefer to work directly with CloudFormation files, which I will find surprising, or working with the CDK, you get the benefits of securing your infrastructure as code by calling secrets that we store securely in our Secrets Manager. And that's it, my friends. I hope that you enjoyed learning how to eliminate secrets from your code, whether that's application code or infrastructure as code. And I will make all this available to you. All the code is available on my GitHub repo. You can go and download it and play with it today. And the slides will be available for you to consume later on. I really appreciate your time. I hope you have a fantastic time at the conference. And feel free to reach out if you have any questions. Thank you and stay safe.